Hey everybody, we're in section 2.3 and we're going to be applying deductive reasoning. Today we're going to have a couple of definitions, maybe actually 3 definitions that we need to talk about. So go ahead and make some space and put today's date. The first thing we need to talk about before we can apply deductive reasoning, we need to actually know what it is. Deductive reasoning is the type of reasoning where we use an established fact or some definitions to facilitate logical thinking. So for instance, if you attend this school, you wear a certain uniform. So if I find a kid who attends this school, I expect that they would wear our uniform. Does that make sense? That's deductive reasoning. There's a law, I apply the law in the situations that make sense. That's how we use it. It's a little bit different from inductive reasoning. Inductive reasoning is when you don't really have a law, but you're looking for a pattern in the information to kind of create a rule or to at least create a projection or a conjecture about what will happen next. Let's look at the next thing we need to talk about. There's 2 important definitions here. One is the law of detachment and the other is the law of syllogism. The law of detachment is really just, again, the way that we logically apply a true statement. So if you know that there's a conditional statement that's true, if you have the hypothesis of that statement, if your hypothesis is true, then the conclusion's going to be true. A little bit weird, but we'll talk about it a little bit more with our example. So the law of detachment is that if you've got a hypothesis of a true conditional statement, then the conclusion has to also be true. The law of syllogism is this. I'm going to read it and then I'm going to give you an example of what this means. The law of syllogism says, if hypothesis P, then conclusion Q. But then if hypothesis Q, then you got conclusion R. Because of that connection of those 2 yellow statements, we really just could have said, if hypothesis P, then conclusion R. Let's go ahead and use an example and see what that means. If you come to school out of uniform, then you're probably going to get a detention. If you're going to get a detention, then your parents are going to be upset with you. I'll do that again. If you come to school without uniform, then you're going to get a detention. If you get a detention, your parents are going to be upset with you. So what we could have done here is just said, if you come to school without a uniform, your parents are going to be upset with you. All right, so let's take a little bit of a closer look at that. Remember, you come to school without a uniform, then you will get detention. If you will get detention, then your parents will be upset. The syllogism here, the bringing it all together, is that you have the power to say it just like this. If you come to school without a uniform, then your parents will be upset. Let's look at example 1. We're using the law of detachment, which basically says if a statement is true, we can then use it as a law because we can start off with a true hypothesis and we know that the conclusion will be true. So here's our situation. We know that if 2 segments have the same length, then they are congruent. So we're given that segment BC, the length of segment BC is equal to the length of segment XY. So what can we conclude? What we can conclude is that segment BC, written like that, is congruent, that's the congruent symbol, to segment XY. Remember that congruent means it's the same length, it's exactly the same in size. You can lay them right on top of each other and one would hide the other. This next one is kind of fun. Mary goes to the movies every Friday and Saturday night. Today's Friday. What do we know? What do we know? If you guessed it, I hope you did, that Mary is going to the movies. That's what we know. So that's using the law of detachment. Here we are with example 2. We're going to talk about the use of the law of syllogism. So, if possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. Let's see if we can do it. Now, to use the law of syllogism, we need to have certain conditions met. And that is, I'm going to go back up to our picture. That is, one statement, we've got 2 statements, right? One statement has to have a conclusion that shows up as the hypothesis. If we have that, then we can tidy it up with the law of syllogism into one conditional statement. All right, so let's go back down to our example and see what we got going on. Here we go. A, if Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. Did you see that? Do you see where the conclusion of one is the hypothesis of the other? I'm going to highlight it for you. With that, we can see that we can take out that highlighted portion and we will have the law of syllogism used to combine these two statements. So now I'm going to write, if Rick takes chemistry this year, then Rick will get an A in chemistry. So if he takes chemistry this year, he's going to get that A based on the idea that both of those statements are true. I'm going to put this out of the way and let's go on to the next term. Or the next part. Part B, it says that if we have a situation where x squared is greater than 25, then x squared is also greater than 20. And then another statement that says if x is greater than 5, then x squared is greater than 25. Woo, right? Again, we're looking for that pattern, y'all. So the pattern is that we want to see that the hypothesis of one statement is the conclusion of another one. And so I'm going to point that out to us in just a minute. Hold on, let me get myself settled over here. Okay, so back to this. The hypothesis of one is the conclusion of the other. Hypothesis of one, there we go, is the conclusion of the other. We've got that together. This time, things are a little bit different. Usually we see it written the other way. Notice that the conclusion of this was the hypothesis of this. So I'm going to call this number 1 and number 2. Let's read it together. If x is greater than 5, then x squared is greater than 25. If x squared is greater than 25, then I know x squared is greater than 20. So do you see how now we're going to rewrite this using this statement first, then this statement next? So our statement comes out as if x is greater than 5, then x squared is greater than 20. Let's go back and look at this last example. It's this last part of example 2. If a polygon is regular, then all angles in the interior of the polygon are congruent. That makes sense. If a polygon is regular, then all of its sides are congruent. Okay, there's something missing here though. What I'm seeing is this. You have a hypothesis that is here and the same exact hypothesis here. But what we see is that one hypothesis leads to two different, true, and important conclusions, but they are not the same. And so the problem with this, in terms of applying the law of syllogism, is that it does not fit the proper criteria, right? Remember the proper criteria, again, and I know this is a little weird, but I'm going to say it again, is that the conclusion of one must be in the hypothesis of another statement, or the hypothesis of one statement needs to be the conclusion of another statement. Since we don't have that, we don't have an opportunity to use the law of syllogism. All right, let's go ahead and use some reasoning here. What conclusion can you make about the product of an even integer and an odd integer? If you're like some students, you probably went and said, all right, let me take an even number, 2, and multiply it by as many different numbers that I can and see what happens. When I multiply 2 times 1, I get 2. 2 times 4, I get 8. Let's make that 8 look good. 2 times 7, I get 14. 2 times 11, I get 22. And after doing this for a while, you're going to realize that all of those values are even. So what I see from this, all of the answers are even. So what I can conclude is that, oh, when I multiply an even integer by some other integer, my final product will be even. When multiplying an even integer with any other integer, the product will be even. Let's go ahead and see if we can look at the difference between deductive and inductive reasoning. Remember, inductive reasoning is looking at a pattern like we did in that last example and kind of seeing where we end up. We ended up with what we think is a rule. It sounds good that two numbers multiplied together or a number multiplied with an even number is always going to produce an even number as long as they're integers. That's true. And deductive reasoning is when we start with a law and then we apply that law. Now that we've looked again at inductive reasoning, let's go ahead and compare inductive and deductive reasoning. So we're going to decide whether or not inductive or deductive reasoning is used in each to reach the conclusion, and then we'll kind of explain which one we think and why. Each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. That's inductive reasoning. Inductive reasoning looks at a pattern of behavior and makes a conjecture about what's going to happen. It seems like this person who made this statement is looking at what always happened before and is assuming that it would happen again. So I would say that this is an example of inductive reasoning. So that's inductive reasoning. Let's look at this last one. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Deductive reasoning often starts with a law or laws or rules that we know to be true, and then we apply it to a specific situation. We know that this parrot here is not a reptile. All right, with that in mind, before you go and before you say you've done your notes, make sure you make an attempt to answer both of these questions. And when I say an attempt, don't just write any old nonsense down. Actually think it through. Once you have done that, your notes are done and you will turn it in to me tomorrow for 20 points. If you choose not to do so, or if you do not do it completely, I will not grade it until it's done completely, and then it will be graded as late. Have a great day, guys. I look forward to seeing you soon. Take care. Bye-bye.